Hi, I hope you all are well and ready to learn how you can host a static website on S3 with a secure connection using HTTPS as well as a custom domain. The clue here is, as you may already know, CloudFront. This is an updated version of my previous CloudFront video, so if you have already seen that one, I suggest you can jump ahead to the section where we start creating the CloudFront distribution. It should be clearly marked with a timestamp. It seems that hosting websites on S3 still is a hot topic. This includes using custom domains and with HTTPS enabled. So if this interests you, just keep watching. In this video, we are first going to learn some basics about CloudFront and why you should use it. In the demo section, I will of course create the CloudFront distribution with a custom domain and an SSL certificate. Afterwards, I will replicate all this using infrastructure as code, more specifically using Terraform. There are some prerequisites for this video. You need to already have a valid domain and SSL certificate to go along with it. If you don't, I suggest watching my video on that topic first. I'll provide a link above now and in the description below. First off, what is CloudFront and what is it for? Mostly, it's a content delivery network or a CDN service. It speeds up the delivery of static and dynamic content such as HTML, CSS, images, etc. to your end users. Think of it as a global cache. CloudFront makes sure that your end users always have the lowest latency possible by storing the content as close to the end user as possible, using something called edge locations. To learn more about this, visit the link in the description. CloudFront also has a lot of other powerful features, such as custom domains and enabling HTTPS using SSL certificates, which we are going to do. It also includes real-time metrics and logging and many cool features like edge computing using Lambda at Edge or edge functions. This is something I'll try to make a separate video about. As you can see, CloudFront does deliver a lot of really great features. Then again, not all of these might be interesting for you. So back to why you should use CloudFront in front of your S3 bucket. You may already know that you can use just S3 to host a static website without the need for CloudFront. Well, you see, by only using S3 static website hosting, you can't have a custom domain and at the same time enable HTTPS, or in other words, a secure connection. For this, we need CloudFront. Also, using CloudFront, the static content of your S3 bucket will be cached in all AWS Edge locations around the world. Meaning, not all the requests have to travel all the way to your S3 bucket to retrieve the static content, which can be located in a completely other region than the end user. Instead, it can automatically be delivered from the edge location closest to them, with the lowest possible latency. As you can see, combining CloudFront and S3 can give some real benefits. It's also worth noting that CloudFront can be used with many other origins than S3. For example, an AWS Elastic Load Balancer or any other HTTP server running on, for example, Amazon EC2 or any other kind of host. Over to today's demo. I'll start by creating the S3 bucket where I will store an HTML file and a picture. Go over to S3, click on Create Bucket, give the bucket a name, but keep in mind that it has to be globally unique or else you'll get an error. I'll call mine Anders CloudFront Test, and let the region be EU Central 1, since that's the region I usually use for these demos. Everything else I'll let be as default. This also means that I will leave block all public access on. This may seem strange, since I want people to be able to access the HTML and picture in this bucket. But I'll soon explain why and show you how CloudFront is linked to this. For now, scroll down and hit Create Bucket. Now that we have our bucket, let's upload some files. Open the bucket and hit Upload. And now drop in the files you want to upload. The HTML file has an image tag with a local reference to this picture, so the picture should show up if we open and render the HTML. Before we continue, if you like my videos and want to learn more about serverless and AWS, remember to subscribe to my channel and smash that bell icon so you don't miss any new videos. Now that the bucket is created and files uploaded, we can get started on our CloudFront distribution. Go over to CloudFront. Click Create Distribution. The first thing we need to configure is the origin, or what CloudFront should point to. From here, I'll choose my S3 bucket as the origin domain. If you want to request a specific path or subdirectory in your S3 bucket, you could provide a path to that here. But since my content is located on the root path of the S3 bucket, I'll leave it blank. You could also change the name of the origin, but I'll let it be as default. This could be useful if you have multiple origins, and yes, it is possible to have multiple origins, for example, multiple S3 buckets connected to one CloudFront distribution. Next, you may remember that we left the permission settings on the S3 bucket to block all access. Well, this is where CloudFront Origin Access comes in. And for those of you who watched my previous CloudFront video, this is the part you want to pay attention to. Origin Access lets us, or CloudFront, retrieve the files from our S3 bucket. And it makes them publicly available even if the S3 bucket has block public access enabled, but only through this CloudFront distribution. So here we have three options. The first one, public, will only work if the S3 bucket is publicly accessible, which it's not in our case. The second one is the one we want, Origin Access Control, or OAC. Using this setting, we can open up access to the S3 bucket for only this CloudFront distribution. The last one, Legacy Access Identities, or OAI, is the predecessor to Origin Access Control. This kind of did the same thing, but OAC has some improvements. There's the fact that the new OAC uses short-lived credentials, which are frequently rotated, to communicate with S3. It uses resource-based policies, and these policies can be reused for multiple CloudFront distributions if you so want. Lastly, you should use OAC since OAI is deprecated. Now, click on Origin Access Control. Since I don't already have an existing OAC, I have to create one. Just give it a name that makes sense to you and hit Create. As you can see, AWS gives me a warning that I have to go into the S3 bucket afterwards to update the bucket policy. The policy needed will be provided once I have created the CloudFront distribution. I'll show you in a few minutes. If you want, you could add additional headers to the request, but I don't need this now. For an additional caching layer, you can enable Origin Shield. This reduces the load on your origin, in this case S3, by increasing the cache hit ratio and can give you better network performance by using origin shields in the region closest to or with the lowest latency to the origin. This does come with additional cost, but not that much. For now, I'll leave it off. Under additional settings, you can also adjust the defaults for connection attempts and timeout to the origin. The next section is default cache behavior. I'll let most of these settings stay as is, like compressing objects automatically, etc. One thing I want to change is the viewer protocol policy. I want to ensure that the connection is encrypted using HTTPS, meaning I'll choose either redirect HTTP to HTTPS or HTTPS only. I want my users to be automatically redirected to HTTPS, so I'll choose that. My users should only perform HTTP GET requests, so I'll only allow that HTTP method. Also, I don't want to restrict the viewer access even more with signed URLs or cookies, so I'll leave that off. This is something I might cover in a future video. Next up is the cache key and origin requests settings. I want to do it simple by choosing a default cache policy set by AWS. More specifically, the caching optimized. It will, among other things, set the time to live for a full 24 hours. If you want to dive deeper into each of them, I'll provide a link in the description below. For this demo, I'll leave the origin request policy blank, but I recommend looking into it to optimize the cache behavior and cache hit ratio for your production applications. Next, you could add function associations for Lambda at Edge or Cloud Functions. This is very useful if you, for example, want to manipulate requests before hitting the origin or the response before it's returned to the client or end user. Web Application Firewall, or WAF, is up next. This is also a really useful feature to protect your applications from common security threats, and is something I would highly recommend for your production applications. This is, as you can see, a feature that comes with additional costs. Then again, I would say it's a small price to pay if it can help protect your business-critical applications. For this demo application, I won't bother enabling it. Okay, scroll down to the settings section. I want to use all the edge locations provided by AWS. This means that the content in my bucket will be cached all over the world and makes sure my users have the lowest possible latency, no matter where they are in the world. If you know that all or almost all your users are located close to a single region, then you could limit the edge locations. As mentioned earlier, I want to make use of my own custom domain for this CloudFront distribution. To do that, click on Add Item under Alternative Domain Name. In here, add your domain, or in my case, a subdomain. For this to work, we need to have the SSL certificate I talked about earlier, which needs to be valid for our domain or subdomain. The SSL certificate has to be created or imported using AWS Certificate Manager. I'll assume you have already done that and created a Route 53 hosted zone. So if you haven't, go ahead and do that by following my video on this topic. One important thing about the certificate is that it has to be created in the US East 1 region, also called Virginia. If not, then it can't be used with any CloudFront distribution. This is just a limitation with CloudFront that we have to accept for now. Now, I have already created a certificate, hence I can choose that certificate here. And of course, you should always select the newest available security policy to go along with it. If you want, you could also enable HTTP version 3. This is for communicating between clients and CloudFront, not all the way to the S3 origin. Default root object is a feature you might want to consider. This way, people visiting your application using your URL don't have to specify a file to access. This is nice if, for example, you are hosting a website using static HTML files, like we are going to do now. Then you can use an index.html file as the root object. This file will then be automatically loaded when people visit your domain. In my case, when users access test.endresynnes.com in their web browsers, they don't need to also provide /index.html at the end to load the web page. These other settings, I'll just let it be as default. And lastly, scroll down and hit Create. It will take some time for the deployment to be complete. So, in the meantime, you may remember the warning that we need to attach a bucket policy to our S3 bucket. We still have this warning here, and AWS conveniently provides us with a button to copy the IAM policy we need. So, go ahead and copy it. Now, keep in mind, it will take some time for the CloudFront deployment to be complete, and I want to see that it is successfully deployed before I continue with the S3 bucket. I'll just skip ahead a few minutes. This took a couple of minutes, and we can see that our distribution is enabled. Now, go over to our S3 bucket. Click on the Permissions tab and scroll down to Bucket Policy. Here, click Edit and paste in the bucket policy. From this policy, we can see that we allow only our CloudFront distribution to perform S3 getObject operations on our bucket. We are almost done now. What's left is to tell our domain provider, in my case AWS Route 53, to route traffic for our domain to the newly created CloudFront distribution. You see, for the alternative domain setting to work, we need to create a new A record in our hosted zone that points to the CloudFront distribution. To do that, go over to Route 53, under Hosted Zones, open the hosted zone associated with your domain, and click Create Record. Since this is a subdomain, I'll enter that here. Again, choose A record as type. I'll use an alias to easily point the traffic to CloudFront, and then our CloudFront distribution as the destination. What you will see now is that we got a strange domain with cloudfront.net at the end. This is the actual domain of our CloudFront distribution. Our custom domain will only point the incoming request to that CloudFront domain. When it comes to routing policy, I'll let the default setting of simple routing be as is. And lastly, hit Create Record. If we open a new browser window and try to access our domain, we should get the HTML in return, and the browser should render it and show my picture. And yes, it did! This means that we now have a functioning website that of course doesn't do very much yet, but it works. The important part is that we can now use our own domain and the connection is secure using HTTPS. Also, thanks to CloudFront or the CDN, we can expect blazing fast loading times for all users across the world. Now that you have seen how it's done using the AWS Console, we can do the same using Terraform. I will assume that you are somewhat familiar with the basics of Terraform, so if you're not, I suggest first watching my Terraform introduction video linked below. Over to your code editor. I have already created a directory containing two files, config.tf and main.tf. If you have watched my previous Terraform introduction video, you may remember that I like to write the Terraform configuration in a config.tf file and the Terraform resources in a main.tf file. This is also the case here. In addition, I have created a directory containing some static files. In my case, an image and an HTML file with a link to that image. In the config file, I have already defined the required provider, AWS. I have also configured the provider with the region EU Central 1. Keep in mind that resources of global services like Route 53 and CloudFront will be deployed in US East 1 anyways. Over to the main.tf file. At the top, I would like to define a couple of local variables. That being the S3 bucket name, which I will set to the same as in the console demo. I have already deleted this bucket, so the name will not collide. Next, the domain, which should be the same. The hosted zone ID of my Route 53 hosted zone. And lastly, the certificate ARN of my certificate in AWS Certificate Manager. With that out of the way, we should create our S3 bucket. This is done by defining a resource of type AWS S3 bucket and using the local variable for setting the bucket name. Next, the CloudFront distribution. You probably guessed it. It's a resource of type AWS CloudFront distribution. The first property we need to set is enabled, which should be true. To use our custom domain, set the aliases property, which require a list, and reference the local variable for our domain inside that list. Default root object should be index.html, and enable IPv6 by setting it to true. I want Terraform to wait until the deployment is complete and the distribution enabled, so set that value to true. Default cache behavior is an object that does require a set of properties. First, a set of allowed methods, which is what HTTP methods are allowed and forwarded to the origin S3 bucket. Also, set the HTTP methods that should be cached. I want to use the same default cache policy as in the console demo. This means that I have to set the cache policy ID property. You can find these cache policy IDs on this website. I'll link it below. So just copy the ID and paste it in here. The target origin ID is of course our S3 bucket, so reference the Terraform S3 bucket resource. For a viewer protocol policy, you can choose one of three options. I want to use the redirect to HTTPS to ensure no one uses HTTP only. The next thing to configure is the origin. This is also a separate block with a set of required parameters. Firstly, set up the domain name where I'm going to use the S3 bucket domain, which you can get by calling the S3 bucket resource again, but this time extract the property bucket regional domain name. Since we are working with a private S3 bucket, we also need to set the origin access control ID. To get the ID, we first need to create an AWS CloudFront origin access control resource. Oh, that's a mouthful. So below our CloudFront distribution, define that resource. Here we need to define 4 parameters. First, the name, which can be anything that makes sense to you. The origin access control origin type should be set to S3. Signing behavior should be always, and signing protocol needs to be SIG v4. With that out of the way, we can get back to the CloudFront origin config. Just reference the newly created resource origin access control to get the ID. Then the origin ID, which is the ID of the S3 bucket again. Here you can choose if you want to extract the ID or the bucket property. It's the same anyways. Then we need to define a restrictions block. Inside this one, we need to set a geo restrictions block. This requires 1 parameter, and that is the restriction type, which I will set to none. Here you could, if you wanted, set geo restrictions on who can access your content, like if you want to block or allow some countries. The last config we need for the CloudFront distribution itself is viewer certificate, or our SSL certificate. Firstly, for the ACM certificate ARN, I'm going to use the local variable created above to set the value. Then the minimum protocol version, which should be the latest available version, in my case TLS v1.2 2021. Lastly, the SSL support method, which needs to be SNI only. Now that the CloudFront distribution config is complete, we can move over to the next thing, which is the S3 bucket policy. This needs to be attached to our S3 bucket to allow our CloudFront distribution to access objects inside the S3 bucket. I'll start by defining a data source of type AWS IAM policy document and inside a statement block. Identifiers should be cloudfront.amazonaws.com. The principals should be of type service to make this apply only for CloudFront distributions. Then the actions. In this case, all we need is the S3:get object. We could also add the S3 list bucket action, but it's not needed for this demo. Under resources, we can define a list containing just the ARN of our S3 bucket, followed by a slash and a star symbol. This is to allow CloudFront to access all objects inside the S3 bucket. We also need to provide a condition block to limit this policy to apply only to this CloudFront distribution. So here, for test, use string equals, and values should be a list containing just the CloudFront distribution ARN. This we can retrieve from our CloudFront Terraform resource. Variable should be AWS:source ARN. Now that the policy is complete, we need to apply it to our S3 bucket. Create an AWS S3 bucket policy resource, and under bucket, reference our S3 bucket again. Policy should reference the data source just created, and more specifically, we want to extract it as JSON. Now all this is in order. All that's left is to create a record in our Route 53 hosted zone so that we can actually use our custom domain to reach our CloudFront distribution and eventually the content inside our S3 bucket. Create a resource of type AWS Route 53 record. The name should be our domain. Type should be A, and hosted zone ID I'll get from the local variable created earlier. To point it to CloudFront, I'll also need an alias block. In here, I need to set 2 parameters. The name, which is our auto-generated domain name for our CloudFront distribution. This I will retrieve from our CloudFront Terraform resource. The zone ID in here is not the same as for the hosted zone for our custom domain. This is a built-in hosted zone for our CloudFront distribution, meaning we can also retrieve this from the CloudFront distribution resource. Now we have defined all the resources needed to replicate all that I did in the AWS console, meaning we can deploy it. Open a terminal in the directory where you have your code, run Terraform init, and then run Terraform apply. If the output looks okay, type in yes and hit enter. This will take around 5 to 10 minutes, give or take, but we can already see from the terminal output that the S3 bucket is deployed. This means that while we are waiting for the CloudFront distribution to deploy, we can upload the static content to our S3 bucket. Go over to the AWS console, and if we refresh this list over S3 buckets, we can see our newly created bucket. Open it and hit upload. I'll drag in the static content and hit upload. As a side note, we could just as well use Terraform to upload these files, but I think it's enough for one video. Now back to the terminal and wait for the deployment to be complete. Okay, it has now gone a couple of minutes and everything is deployed. Open the AWS console and go over to CloudFront. Here we can see the CloudFront distribution and the status says enabled. I'll copy the URL and paste it in a new browser window. And yay, we did get the same response as we did using the AWS console. Only this time, it all got deployed using Terraform. I hope both the console demo and Terraform demo was helpful. Please do leave a comment if it was, and especially if you have any suggestions or ideas for improvement in future videos. All that's left to say now is, until next time, happy coding!